Welcome to our Sandbox Bone Fracture Detection Project. My name is Odin Lundstam.
I'm Zornigor Solikova.
I'm Prabha Prakash.
I'm Tyler Lee.
And I'm Agan Attila. And to begin with, worldwide, on average, 1.71 billion patients suffer from musculoskeletal problems. And in emergency situations, there's a high likelihood for misdiagnosis of fractures. And therefore, our goal for this project is to create a program which accurately and efficiently classifies closed and open fractures.
To begin with, these are the pictures that we chose for our X-ray scans to feed into our program. We decided to choose images that had a very extreme or severe fracture site, just so it was easier for the initial code to process the image. So to start off, we did some user input work where you input the image so the file can be analyzed, and then we moved on to some image processing, which is then followed by some thresholding, and then after that we did some region analysis using region props and bounding boxes. The result of that was then fed into direct fracture classification and detection.
We split our code in multiple components, and for the first component, we focused on user input and image processing. So going over the component one, we first did user input, where we would prompt the user to put the file of their broken bone and their patient name, which would be later stored in a CSV file, which we'll go over in component 4. Then we went on to image processing, where we first did IM resize to resize the image. Then we would grayscale the image using IM to gray. Then we would reduce the grayscale intensity, so it would be easier to binarize. Then we use IM resize to make it a 700 by 500 pixel count, which would be later used for retesting purposes. And I'm going to pass it off to Odin for thresholding.
All right, so we originally tried to do an advanced threshold that could adapt to all sorts of different images. However, the information stored in just one image proved far too great for our simple toolbox of tools. So instead, we went with a single thresholding technique using if-else statements to find the best grayscale intensity for our images. Then, in region detection, we converted this thresholded grayscale image back into binary. Using region props, we found the two largest bounding boxes within the image, and if there's two bounding boxes, we knew that the bone would be broken, and if one bounding box greatly outweighed another bounding box, this process would recognize that the bone is in fact not broken, and this would be one giant bounding box, and it would be green, saying the bone is all good.
Alright, so as stated earlier, bounding boxes show whether there is one bone or two bones that caused by a fracture in the first bone. So we extracted the bounding boxes as shown earlier, and then we determined which of the bounding boxes representing each part of the bone is higher and which part is lower. After that, we extracted the corners of said bounding boxes, the coordinates, and found the vertical and horizontal distances between the intersection of these bounding boxes to determine where the fracture is located. So we then labeled the fracture by drawing a bounding box around the intersection of the two big bounding boxes, and we displayed the binary image with the labeled fracture. And then to classify the fracture, we looked at the displacement between the bounding boxes, and then if the displacement passed a certain threshold, it would be a compound fracture, which is larger compared to a hairline fracture, which would be the case if the threshold is lower.
Finally, we did a save results tab, where we would save all the data that we gathered into a CSV file, which would be easier because we focused our code on clinical use. So a doctor can access the CSV file, open it on Excel, and access the patient's name, the type of bone breakage that they encountered, and which date that it was recorded in.
So this was the raw initial image that we fed into our program, and the next image is the outputted result that the program produced. So as you can see, the fracture site is clearly labeled with a red bounding box. And this is our team contributions.
And for future directions, we want to plan on improving image pre-processing and quality checks by implementing automatic checks to detect low-resolution images or those with excessive noise. And we also would want to implement Gaussian filtering to smoothen out any excess noise. Additionally, we would want to work on fracture tracing and range determination, and develop a tracing algorithm to track fracture lines. This would allow us to expand the amount of the types of fractures that we can identify through this code.
In addition to that, we also want to try implementing machine learning, such as using networks, models such as convolutional neural networks for more complex performances that our code can do. And furthermore, as Tyler mentioned, if we want to design it for clinical use, we can also implement the code to be able to process multiple images at the same time using batch processing, so that multiple X-ray scans can be inputted and multiple outputs can be outputted.
And these are our references, and thank you
Thank
so
you.
much.